Okay, question 6. So, just quick recap so far. We've gone through some percentages. I would say this is almost similar to percentages in a way because it's a wee bit like reversing the change or a little bit. Um, but yeah, some percentages. Then I would say it's basic maths. Um, Very easy vectors. The factorizing, quite a straightforward question. In the end, like I said before, there's a few different things to consider. But yeah, bit of factorizing, and then some angle chasing, which was a little bit trickier. I keep forgetting to do some of the marking because they're quite easy questions. I did the marking for the 3 points at the beginning. I forgot the marking here. You were actually just getting a mark for your 37, a mark for your 53, and then a mark for your 74. Okay. The other ones are pretty self-explanatory. In this one again, you get a mark for your common factor of 3, and then a mark for that. Okay. So sorry if I've not been marking all the way through, but there's been quite small questions. For something like a 4 marker, I'll definitely remember. Okay, so 5 questions down, and how many to go? Let's see, we're going up to question 15, 60, 16. So we're about a third of the way in. All right, nothing too scary so far. Okay, right. So Jack called his internet provider on 6 occasions to report connection problems. On each occasion, he noted the length of time he had to wait before speaking to an advisor. Jack sounds like a very fun guy. The times were as follows. So calculate the mean and the standard deviation. So these are the 6 days: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, whatever. And this is the number of minutes he was sat waiting for his call to get answered. All right. So when you get one of these questions, brilliant. I just think the statistics is very prescriptive, very straightforward. Yeah, I think these are just marks in the bag. So first thing I would do is write them out in order. Okay, so I'd say 5, just from lowest to highest. All right. 10, 12, and just score them out as you go. 13, 16, and then 22. So lowest to highest every single time. Sometimes they give it to you in that order, sometimes they don't. Okay, if they don't give it to you in that order, it just, well, you don't have to, okay, but I think for other questions, it just makes life a lot easier. Okay, so that's us in order. The first thing we're going to do is work out our mean. Okay, so the mean is x bar. And x bar is just going to be equal to the sum of all the x's divided by how many there are. Okay, so we're going to do 5 plus 10 plus 12 plus 13 plus 16 plus 22 divided by n. Okay, so that should give us 78 divided by 6. Again, it is a calculator paper, but just think, you can always do these things as well. You don't have to do it all on your calculator. But yeah, so x equals 13, and technically unit-wise is 13 minutes, okay? Despite what my handwriting looks like, it is minutes. Okay, minutes. Alright, so that's our first step. The next step, when you see this, is just to go back to the beginning and check your formula. Now, the formula I like to use is this one. I think this is the easiest one to use, okay? So we're going to do x minus x bar squared, the sum of them, divided by n minus 1. So we'll just write that over here. We'll just say the standard deviation is the square root, the sum of x minus x bar squared, divided by n minus 1. And so it looks very complicated. That's why I like this. It's 4 marks for actually what is very simple. Okay, I'm the first person to say during these that, oh, this is tricky, this is not tricky, but this really isn't tricky at all. Okay, so we've worked out the mean, which is x bar. Okay, now at that point, I'm just going to check the marking scheme to see if it says you have to say mean. I think you probably got maybe just leaving it like that, to be honest, but maybe just to be on the safe side, you might want to say mean equals 13, okay? And then the marker knows where you're at. But I think really you don't need to write that. I think if you're writing X bar, they should be happy, okay? But let's just write that anyway. So we know the mean. So we've actually worked out already X bar. So the next thing we're going to do is work out this entire term. Okay, so we're just going to make a little table up. We're going to do X. We're going to do X minus X bar. We're going to do X minus X. Oh, sorry. X minus X bar squared. So I'm just going to put some straight lines. I'll do my best with the straight lines. Okay. Oops. I mean, if you learn nothing from maths, at least there's an entertainment value of just watching me be rubbish with lines. Okay, so x is just our numbers, right? So we've got 5, 10, 12, 13, 16, and 22. Now, I like to write it from low to high because at this next point, there's a bit of a pattern, okay? So if we say x minus x bar, so 5 minus 13, that's going to be minus 8, okay? 10 minus 13, minus 3. 12 minus 13, minus 1. 13 minus 13, 0. 60 minus 13, 3. 22 minus 13, 9. Okay, so it goes from the lowest to the highest. Now if I add this up, okay, so 9 plus 3 gives me 12. Minus 8 minus 3 minus 1 gives me minus 12. Okay, so see all of them give me minus 12, and then these give me 12. 12 minus 12 is 0. Okay, that's how you know you've done it right. Okay, if these sum up to give you 0, you know at this point you're right. If actually your signs were round the wrong way, but the numbers were okay, it would still come out in the wash at this next bit. I think it's good to make sure your signs are okay and your numbers are okay, just to get that 0, just so you know you're on the right lines. Okay, so some people would just look at the difference and say, we just write down here, they would just write 831039, and then they would square it, and it's about the next term that gives you the mark anyway. Just check that, but I'm sure that's right. Yeah, it's this term that gives you the mark, so you don't have to work it out exactly, but I prefer doing that. Okay, just give it a bit of peace of mind. Okay, so I've done it low to high. I've got all my negatives and positives correct, and I've got this 0. So I just feel like it's neater, it's easier to spot mistakes. All right. So x minus x bar squared is basically just saying this term here squared. Simple. So I've got 64, 9, 1 squared is 1. Okay. 0, 9, 9 squared is 81. And I'm going to add them up. So what's that going to give me? Be 164. Now, if it was non-calculator, I'd be thinking that's definitely right because it sounds like a nice kind of square rooty number. But I thought, yeah, I forget that. If this is non-calculator, it would be numbers that would reduce well. Okay, but for this paper, it doesn't really matter. Okay, so now I'm going to substitute into the equation. So the standard deviation is the square root of 164. We just said was this number divided by n minus 1. Now it's 6 results, minus 1 is going to give me 5. Okay. Now again, if you're doing the non-calculator paper, that is the same as root 164 divided by root 5. Okay. And then they might get you to reduce that down. Okay. So we don't need to do that here, obviously. We can just use our calculators, but that's a potential option for you if you get a question like that. That's going to give me 5.7, and don't forget what it's in minutes. Okay, so standard deviation is 5.7 and the mean is 13. Now let's see what the marks are for. Mark for the mean, mark for calculating this, substituting it in, and then solving. Okay, so 4 very easy marks. You've not done anything, I don't think, particularly hard. I think factorising is probably harder, and there's only two marks up there for the factorising, because that just draws on your knowledge of lots of things run through your head when this happens. You think, oh, we're doing complete the square difference. Oh, was it complex? Oh, it looks complex. It sounds there's a lot in there. But for this, every single time, put it in order, working out your mean. You've got the equation. You're just trying to work out x minus x bar squared. Dead straightforward. All right. Time. Plenty. Okay, so just to recap that then, what was his name? Jack. So that was a mean of 13, standard deviation of 5.7. Okay, so Jack his x bar was 13, standard deviation was 5.7. Okay, now Sophie. She's done the same thing. She's another incredibly exciting human being, and her mean waiting time was 15, and the standard deviation was 4.3. Okay, so what's happened from 13 to 15? What's happened to the mean? Okay, so the mean's gone up between Jack and Sophie. Okay, and what's happened to the standard deviation? It's gone down. So what would we say then? Well, I'd say that Sophie and this is the phrase that you always want to put in, on average has a longer wait time. Okay, because he's got it has a longer average or mean wait time. Okay, and that's quite a good way of putting it. Sophie on average has a longer average wait time. Sounds like all of averages. Sophie on average has a longer wait time. It's probably fine, but as a longer wait. Yeah, you know what? It's probably don't need to put the average actually. Yeah, it's just too many averages. So on average, she's got a longer wait time because 15 is higher than 13. Okay, but her standard deviation was less. Okay, so what does that mean then? So I always think of standard deviation as like the spread of results. Okay, so the spread of her results was less than this spread of results. Okay, so they were more consistent. Okay, or there was a smaller spread of results. Okay, so it was like a smaller range of results or more consistent results. Okay, so Sophie's wait times were more consistent. Okay, so what about the mean? What about that? So a mark for each, obviously. And I would just start off this little table just to make sure you're getting the right gist. Okay, so this is the one that people forget. It's easy to, as there's two things. First of all, tie it into the question as much as possible. Don't just say the mean was higher. Well, the mean what was higher? The mean wait time. On average, the mean wait time was higher. Okay, she waited longer. The more English you can put into it, the better. Okay, so on average, Sophie's waiting time was longer, and the waiting times were more consistent. Okay, you can even say there was less of a spread. Okay, the spread of the range of results was lower. Would probably be okay as well, I think. But actually, in the market scheme, the phrase they've used is Sophie's waiting times were more consistent. And I like the idea of consistency. I think that kind of rings true for me when I think of the standard deviation. It's all about how consistent the results were. Okay, it's just like if you were, playing darts, how consistent, if you were aiming for the bullseye, how consistent were you? Were you always hitting the bullseye? Were you all over the shop? Okay, so jacks were just maybe if you could represent Jack and Sophie as dartboards, jacks were a bit like this, and maybe Sophie's were just a wee bit tighter. Okay, so more consistent results. There was less of a spread, less of a range of times. In fact, maybe saying range isn't the best way of doing it because that's something different, I suppose. There was less of a spread, or it was more consistent. Point there. Okay, but so I'm just trying to make you think about what these things actually mean. All right. Yeah. So great question for that one. Thank you, Lucky Stars. Okay, 4 marks. That's nearly 10% of your marks for substituting. In fact, with the 2 here for the analysis, that's 6. So more than 10% of your paper, okay, is just on an equation you've been given and substituting it. And that's very straightforward. All right. So that's a great question. I'll stop here.